Right, so last question. Very much a bit like chemistry. Okay, so I'm sure Miss Locker or whoever you have for chemistry has taught this a lot. If you see a curve like this and it's talking about rates or decay or something like that, you are almost certainly going to have to draw a tangent. All right. So figure 16 shows how the number of atoms of radioactive element in a sample varied with time. So you can see over time it starts to decrease, but it's not linear, it's curved. Activity is the rate at which source of unstable nuclei decay. Determine the activity of the radioactive sample at 300 seconds. Give the unit. Okay, so this is reasonably easy. You've just got to draw your tangent right. All right, so you need your ruler. Right, so it says at 300 seconds. So what we do is we draw a line up at 300 seconds. Okay, now what we then have to do is be really careful with our ruler and only allow our ruler to touch the curved line at that point. Okay, so really it's really hard. That's why they'll give you a range of results. And you want to make sure this little area here between the ruler and the line looks roughly symmetrical to that area. Okay, and you want to do it in pencil, unlike me who's doing it in pen. Okay, now I'm reasonably happy with that. So you can see it's only really touching the line at that point, and we've roughly got the same sort of symmetrical shape on that side and that side. Okay, so that's our tangent drawn. Okay, if we've got a tangent drawn like that, we will get one of our 4 marks. Now what we do is we measure the height. Okay, so the height of it from there to there. This is the advantage of drawing from axis to axis. It makes it easier. Okay, so our height is from this point to this point. So we'll see, it doesn't, annoyingly, it doesn't quite reach the bottom. It stops there. Okay, so we've got to get our triangle. That's why you do it in pencil, because that wasn't quite right. And we go across. So here, this was at 0.2 and this one's at 5. So the height of that is 4.8. Okay, so y equals 4.8. Now we need x, and x goes from 0 all the way across to here. So these go up in tens. Let's just check. 5, 10, 5, 20, 30, 40, 50, 60, 70, 80, 90, 600. So that means that's 610, 620, 630, 640, 650. So our x is 650. Okay, so that means we've got a y and we've got an x. And that's how we work out our tangent. We do our vertical, which is our y, over our horizontal, which is x. So tangent equals y over x, which is 4.8 over 650. Okay, and in fact it's not, it's 4.8 times 10 to the 23, I apologize, divided by 650. So that should be 4.8 times by 10 to the 23. I almost forgot, don't you forget, that's 10 times to 23. So remember, 4.8 times 10 to the 23, don't forget to add that onto the end. So then we're dividing it, so what we do is we put that into our calculator with our fraction button. 4.8 times by 10 to the 23, and then we've got to divide that by x, which is 650. That comes out as 7.38. Okay, 7.38 times by 10 to the 20. Now, looking at the mark scheme, okay, it says the correct answer is 7.1 times 10 to the 20. Okay, you can see we've got 7.38 times 10 to the 20. Okay, but it accepts any range from 6.5 times 10 to the 20 to 7.6 times 10 to the 20. So you can see we're well within range of that. And the units for activity rate is becquerel. So you just remember it's BQ, like that. Capital B, lowercase q. Remember that for radioactivity, okay? Or decay rate is becquerels. Hopefully that helps. Thank you.